topic, we are going to be looking at the integration of exponential functions 1 over x as well as 1 over ax plus b. So since we learned that the differentiation of ex gives us ex, that is clear that if you were to integrate ex, okay, we are going to get ex as well. Okay, so that's needless to say. But of course, okay, with any other integration, we always have to add a constant because the constants are always being differentiated away, so we need to reintroduce it if we were to be integrating. So if we were to be integrating the exponential function e to the power of ax plus b, then we are also going to get the same thing, e to the power of ax plus b, but not forgetting that we always have to divide by the coefficient of x. So that's a, okay, and then also plus c. Another way to write it will also be this, so both are actually meaning the same thing. Okay? So, looking at try 12, if we are looking at integrating e to the power of 3x plus 1, okay, what would the answer be? Kenneth, what do you think?
1/3
Okay, great. 1/3 e to the power of 3x plus 1 plus c. Okay. Now what about 1 over 2 e to the power 1 minus x? Okay, notice that our exponential function here is in the denominator, different from how we have it in our formula. So we need to do some form of manipulation. So this actually means 1 over 2 times e to the power of negative 1 minus x. Okay, we can bring the negative sign inwards. So we're looking at half e to the power x minus 1. You could also consider putting up in the numerator, that's fine as well. So therefore the integration of half e to the power of x minus 1, what do you think the answer would be, Kelly? Half e to the power of x minus 1 plus c. Great. Okay, there's no coefficient for the x, or rather it's a 1, so we don't have to explicitly write down the division of 1. Taking a look at try 13, we are given that dy over dx is equals to 1 plus e to the power of negative x, and also y is equals to 4 when x is equals to 0. We want to find the equation of the curve. So that tells us that we have to first integrate 1 plus e to the power of negative x. Okay. By the way, I noticed I also didn't quite mention, we don't usually write this. Okay. In case you have thoughts of writing this, we don't write it this way. Okay. It is not quite sensible in notation-wise, right? So usually we just write the entire function that we're supposed to integrate. So continuing with this, we will be getting, what will we be getting? Maybe Sing, what do you think? How do we integrate 1? X, okay, good start. Then how do we integrate e to the power of negative x? integration of exponential is always keep the same thing divided by coefficient, right? Okay, so what do you think it should be over here? You keep the plus. Integration of the e to the power negative x, we will get e to the power negative x over negative 1. Anything else? Plus c. Okay, great. Then we simplify this. This is what we get. But we're not done with this yet. Okay, because question gave us additional details. There is a specific equation when it comes to the curve. This is just a very generic equation because we don't know what is c. So, okay, when at your 0, 4, y coordinate is 4, x coordinate is 0. Be very careful, e to the power of 0 is 1. Don't assume it to be 0. So c is equals to 5. Therefore, y is equals to x minus e to the power of negative x plus 5. Okay. Next, we take a look at question 11. That's in your textbook, page 110. With y equals to fx such that its derivative is e to the power of negative 3x plus 3e to the power of x. Take note that this is the derivative itself. This tells us that your dy over dx is in this expression. Part I wants us to explain why is it that this curve has no stationary points? What is our understanding about having stationary points? What's the condition that must be fulfilled? dy over dx equals to 0. So yes, I mean having stationary points means that dy over dx is equals to 0. But since we're not talking about no stationary points, we are trying to address that dy over dx is not equals to 0. So having to say that it is more than 0 or less than 0 satisfies the idea that it is not equals to 0 already. Okay? So, looking at your dy over dx over here, looking at how the expression is like and what is in the expression, we notice that we have e to the power negative 3x as well as e to the power of x, or rather specifically 3e to the power of x. Okay? They are both exponential functions. Exponential functions are always greater than 0. Okay? So, since e to the power negative 3x more than 0 and e to the power x more than 0, surely having both to be more than 0, if you add them up, okay, dy over dx will be more than 0. Okay? So because it is more than 0 and not equals to 0, we can conclude that, therefore, y equals fx has no stationary points. are always positive. That's something that you must know. Okay, you can think about it as though like how COVID started, okay, how it went up exponentially is because there is always that one case first, okay, and one is always a positive number such that it can escalate upwards. Okay, so that's how exponentially increasing comes about, right? Okay, so going to part 2, given that the curve passes through 0, 3, we want to find the expression for fx. Okay, so that means we have to integrate our dy over dx. Subsequently, put in the point here, which we just covered. Okay, then we will be able to get what is fx. Could I give you just 5 minutes, okay, to solve this question? Figure out what is fx. Okay. I'll leave the seats at the back, yeah? most of you are getting it right as well. So your constant should be a 1/3. So we should be getting this as our final answer. Alright. I generally don't see much issues when it comes to integrating. Okay, so let's move on. Okay, and look at how do we integrate 1 over x and 1 over ax plus b. Okay. So why is it that we're looking at integrating 1 over x and 1 over ax plus b? Okay, didn't we already cover it in 16.1? Right? The thing is, in 16.1, we did not actually talk about integrating this, okay, because our powers, okay, that we discussed in 16.1 are all actually more than negative 1, okay, or rather not equal to negative 1. Why is that so? Because we know that when we did our differentiation, when we have to differentiate things like, for example, ln x, okay, we know that we are getting 1 over x, okay, so I cannot think of integrating 1 over x as though it is to the power of negative 1, and then think of it as, oh, plus 1, then becomes 0, then after that you divide by 0, doesn't quite make sense, right? Okay, so we don't do that when it comes to power of negative 1. Okay, so because of this thing in our differentiation, when we integrate our 1 over x, we should actually get back our ln x. Okay, then don't forget to plus c as well. Okay, likewise when it comes to learning how to integrate, differentiate earlier, when we differentiate d over dx, our ln ax plus b, we learned that it will be 1 over ax plus b times a. This will tell us that if I were to integrate 1 over ax plus b, I should get back our ln. We need to divide the a away and remember to plus c. Okay? So be very careful when it comes to integration of algebraic expressions to the power of negative 1. Okay? Let's look at some examples. Looking at try 14, part A, when I want to integrate 2x minus 3 over x, so we would not have any quotient rule or anything. So simplifying this first, we are looking at 2 minus away 3 over x. Okay, your 3 over x is the same idea as 3 times 1 over x. So as we integrate 2, I will get my 2x minus away 3 ln x. And not forgetting to plus c. So the integration of 1 over x becomes your ln x. Yep. Sorry, what do you mean? Yes. Or what are you thinking about? Integrate 1 over x will give you? Or what are you thinking of? You're thinking of using 16.1 stuff, is it? 16.1. Okay, maybe let me just erase this first, yeah? Okay, so just now I was just mentioning, in 16.1, right? This was the power rule that we learned. Okay, I didn't go into the final details of the conditions and all that. Okay, so this was what we learned, right? Okay, and if I were to, some examples that I gave you was that if I'm looking at integrating x squared, I will be getting x cubed over 3 plus c. Right? This is what we covered. Okay. But if I want to apply to 1 over x, 1 over x, we know that it is to the power of negative 1. We apply the same rule. Negative 1 plus 1 is 0. Okay, I still need to divide by that power itself, plus c. But we know that this is undefined, right? Okay, we cannot divide anything by 0. In fact, x to the power of 0 is 1. Okay, 1 divided by 0 is not defined at all. It is not equal to 0. Okay, so that's why this rule actually fails us in some sense. Okay, and it is not true also because we very well know that if I want to differentiate this, okay, my differentiation doesn't allow me to differentiate this also. Okay, and it shouldn't be giving me this back. So by understanding that our integration and differentiation are actually opposites of each other, okay, since we know that differentiating our ln will give us this, then strictly speaking, integrating 1 over x will give us back our ln x. Okay? Alright, so I hope that this clarifies that. Okay, let me flip my pages again. Moving on, part B. When we integrate 1 over 1 minus x, we will get ln 1 minus x. Don't forget to look at the coefficient of x. In this case, it's a negative 1. We need to divide by that. So divide by negative 1. And the very important plus c. So it is negative ln 1 minus x plus c. Okay? Then part C. Okay, integrating our 1 over 3x minus 2. What should our answer be? Joseph, what do you get? Ln 3x minus 2 over 3. We think. How? Just missing something, that's all. Plus C. Okay? So this will be the integration. Right? Okay. Next, we look at try 15. Whereby we will learn a new skill. It's very important when it comes to integration. We will do some recapping of our partial fractions. Okay. Notice that in this question, if I want to integrate 1 over x plus 3 and 2x minus 1, okay, our rule here doesn't apply because we are strictly only looking at one linear factor, okay, ax plus b. I'm not looking at double of it, alright? So in this case, if my end goal is to actually integrate this, okay, I need to make use of partial fractions so that I can actually split it up into 2 single fractions with some single linear factors, then I can apply my formula understanding over here. Okay, so the first thing that we should do in part I, which is to do partial fractions. In case you have already forgotten your partial fractions, I recall that I have this inside the formula list. Oh yeah, I'll bring it up today. Okay, I think I put it in the formula list. Do you have it? Okay, the mini booklet. Have? Is it inside? Yeah, so please refer to that to refresh your memory. So over here we are looking at distinct linear factors, linear meaning power of 1. So our fractions should be a over x plus 3 plus b over 2x minus 1. Okay, where we need to go and find out what is a and b. So multiply across the whole thing by this big denominator here. So this becomes 1. A over x plus 3 multiplied by this denominator will be left with a times 2x minus 1 plus b times x plus 3. Okay, hope that you can follow me algebraically. Then we find out what is a and b. We can use, I forgot the name already, substitution rule or something like that. Okay, so so names, this kind of name is not very important. Don't use it often. Okay, so if I let x equals to negative 3, it will become 0, so b disappears. That's how we find our a. So when x equals to negative 3, 1 equals to a, 2 times 3 minus 1. So that's my a. Therefore, a is 1 over 5. Okay, then now...
No, it's something positive 3.
Huh? Oh, sorry. So the negative is negative 7 then. Right? So a is negative 1 over 7. Okay, then we sub in to get rid of this a over here. What should we sub in for x? Again, what should we sub in for x? To make 2x minus 1 equals to 0. Oh, should we be? Huh? 0? I want 2x minus 1 to be 0 then. What should x be? Do a calculation now. 2x minus 1 equals to 0, so half. Okay, so when x equals to half, 1 equals to a times, sorry, don't need a anymore. E times half plus 3. So 3 and a half, that is 7 over 2. B is equals to 2 over 7. Not forgetting, we do not stop here. We are not trying to find a and b, we're trying to put it into partial fractions. So, answer the question. Original fraction now becomes, okay, a is negative 1 over 7. Okay, I know that sometimes you struggle when the constant is actually a fraction, what to do. It is actually negative 1 over 7 is in the denominator x plus 3. Okay, please get used to that writing. Plus, b is 2 over 7, so 2 over 7 bracket 2x minus 1 in the denominator. So that's the answer. Okay. Okay, then part 2. Okay, this is how partial fractions is very commonly tested as part of integration rather than an independent question. So part 2, we want to find out what is the integration of the original question. So we don't have the capacity to integrate that, we have to split it out into different fractions. That's why we did this. So this integration is equals to negative 1 over 7 times x plus 3 plus 2 over 7 2x minus 1. If looking at this is tough, okay, for you to figure out what integration is, you may want to consider writing it in this manner, which is its equivalent. Okay, because when fractions multiply, numerator times numerator, denominator times denominator. So 1 times 1 gives us 1. 7 times x plus 3 gives us this. 2 times 1 gives us 2. 7 times 2x minus 1 gives us this denominator. Okay, so now integrating it, negative 1 over 7 I could ignore, but that doesn't mean I don't write it, I still write it down. 1 over x plus 3, to integrate that I will get ln x plus 3. Divide by coefficient of x that happens to be 1. I'll just be clear over here, so I'll just put it here. In case some of you don't catch what I just said. Plus 2 over 7. Integration of 1 over 2 minus 1. 2x minus 1. I'll get ln 2x minus 1. Divide by 2 coefficient of x. Don't forget to plus c. Okay, then simplify. This can cancel. Sorry that it's a bit messy around the corner. If you want to, you can combine it to same fraction since the denominators are both the same. Okay, but not an issue to have left it over here like that as well, unless the question expects a certain form. Okay, maybe in case okay, exam expect a certain form. Actually, this one can simplify further. So we are looking at negative ln x plus 3 plus ln 2x minus 1 over 7 plus c, which essentially is a 1 over 7 multiplying with these two. So let me just rearrange that. I'll put the minus 1 at the back. Okay, when two logarithms minus each other, can combine it and express as a fraction like this, your logarithm loss. Okay, then plus c. Right? So depending, okay, on the question, adapt accordingly to the context. Now let's move on to look at another question. Let's integrate this one. Denominator is x squared minus 1 and x plus 1. Okay. Clearly, we have to do partial fractions, right? Okay, because the denominator is not something that we can handle. So let's just extract out that fraction without the integration. Okay, what should its partial fractions form be? Wait now, what should the partial fraction form be? refer to the formula list. How should I express this in partial fraction? A over plus what? B over x plus 1. No? Then? So say again? Okay, over what denominator? Okay, ax plus b over x squared minus 1, then plus c over x plus 1. Like that? Okay, this is what Rina has given us, right? May I just find out how many of you agree with this? Oh dear. Okay, who disagrees with this then? Okay, then the rest of the class? Please don't be lazy. In the exam is you take, not I take. Can't be with you forever. Okay, so how? Look at the formula. Right, tell me what should be appropriate answer be then. Joseph, since you disagree, what was your recommendation?
A over x plus 1. Over x minus 1.
Sorry, A over x plus 1 then?
B over x minus 1.
B over x minus 1.
And then C over x plus 1 squared.
Oh. Joseph gave this. Feels like there's some contention. So how? I mean, is this what you have disagreed and wanted to give as well?
X squared minus 1, right? This bracket x minus 1 and bracket x plus 1.
Okay, so Bobby said that yes, he agrees because x squared minus 1 is x plus 1, x minus 1. Okay, so therefore, x plus 1 gives us this. So essentially, the question's fraction is actually 1 over x plus 1 square x minus 1. Any issues in this algebraic manipulation? Do we all agree with this algebraic manipulation? It's true, right? Okay, x squared minus 1 is x plus 1 x minus 1. Then combine like that. Okay, so then the issue falls back onto what should the partial fraction form be. Okay, if you remember, there are 3 different types of partial fraction forms. One of it is about linear vector, your x plus 1, okay, or even your x plus 3 just now. Okay, so these are all linear expressions, power of 1. Alright, second one is a repeated linear factor. What do I mean by repeated linear factor? It is when we have your x plus 1 squared. X plus 1 on its own is linear. When you square, it becomes repeated. That's why we call it repeated linear factor. And when we have a repeated linear factor, okay, if you go back onto your formula list, you need to go and see what I write. Okay, in your page 2, okay, your gx, if you have it, okay, contains ax plus b bracket squared. This one. Okay, so this is your repeated linear factor. It generates 2 partial fractions. One of it is power 1, the other one is power 2. Okay? Alright, I hope that this is time for you to go and revise A-Maths, okay? Prepare for your mid-year exam. Then the third type, okay, is when we have a quadratic factor that cannot be factorized anymore. Example, x squared plus 1. Okay, so x squared plus 1 itself cannot factorize anymore. Okay, so let me just summarize. Case difficult for you to follow in speech. So example 1, basic. Okay, singles. Okay, we get single fractions. Part number 2. Repeated. This one repeated. Okay, so we have your a over x minus 1 plus b over x minus 1 squared plus c over x plus 1. Third one is s squared plus 1. Issue here is this one. Okay, hope you recall this. Let me just cover it. Okay, clear? So in your textbook, I recall chapter 3, this one called repeated linear factor. This one called quadratic factor. Quadratic factor may not always look like this. So other way that it could look like s squared plus, let me think of 4x plus 7. Cannot factorize. Okay, so it's a quadratic factor, cannot factorize one. Okay, cannot further factorize that. Alright, so summary, combining what Mervin and Joseph have given us, we are looking at a partial fraction form to be like this. So continue to find out what is A, B, and C. 1 is equals to A times x squared minus 1 plus B x squared A. Yeah. Oh, sorry. Yep. No. A times x plus 1, x minus 1 plus B x minus 1 plus C x plus 1 squared. Okay, it is a multiplication of this for all. Okay, each fraction multiplied by this denominator here. Okay. So that's why your x plus 1 already removed. We have one more x plus 1, single x minus 1 plus b. X minus 1 is left because this one cancel. While for the c, x minus 1 cancel. So left with x plus 1 squared. Okay. Please don't blindly copy. Make sure you understand the algebra. Then we sub in numbers. Okay. Let x be negative 1. Then becomes 0. Becomes 0. Okay, your A and C becomes 0. So B is negative half. Then let x equals to 1. A is still 0. B is 0. C is 1/4. look at the last one. You can choose to have x to be any number. You want to choose 1 billion also can. You will press your calculator until you die. Okay. Just choose simple numbers, 0 will do. So 1 equals to a times 1 times negative 1 plus b, which is negative half times negative 1 plus c, which is 1/4 times 1 squared. Plus half plus 1/4 plus 3/4. So a is negative 1/4. Okay, so we got our A, B, and C is ready. Therefore, we're already done halfway. Our fraction is equals to A, which is negative 1/4 x plus 1, B, which is negative half, so minus half x plus 1 squared, plus C, which is 1/4 x minus 1. So I substitute into this partial fraction form here. Questions? Okay, so we're looking at integrating negative 1/4 x plus 1 minus 1/2 x plus 1 square plus 1/4 x minus 1. Okay, we know that integrating negative 1/4 x plus 1 will give us negative 1/4 x plus 1 become ln. Okay, then after that, we will get this as our answer. Am I right? Do put in some thought. Am I right? I'll guess that Bobby might know. Okay. Let's see whether the rest of you are able to see. Yes, we. X plus 1 bracket square, yes. Integrate the other way. So Wayne says that this integration here is wrong. But why? 1/what? Miss Pang say 1/something become ln. It's not 1/something become ln. Correct or what? No? Okay? It's not like that. Okay, so capture the concept correctly. The power is always negative 1. So actually it's 1/x plus 1 is your x plus 1 to the power of negative 1, right? But in this case, your x plus 1 square is actually a x plus 1 to the power of negative 2. So when it's a negative 2, we have to do it the chapter 16.1 way, which is our power rule way. Okay, so please be very careful in the way you integrate this one, which should in fact be looking at integrating. Sorry, let me just write this very loosely here. Okay, 1 over 2x plus 1 squared is the same as half x plus 1 to the power negative 2. So it is a half. Then this thing, power plus 1, so that's negative 1 over negative 1. Okay, coincidentally, the coefficient of x is 1, so it's just a times 1. Okay, so please be very careful about that. Therefore, to simplify, we have this. Since just now we have learned how to simplify ln a bit, so let's just work on simplifying that. This one both 1/4. It's as good as writing 1/4 ln x minus 1 minus 1/4 ln x plus 1 plus 1 over 2 x plus 1 plus c. The ln effectively could become 1/4 factorized out x minus 1 over x plus 1. Okay, let me highlight that for you. Just shifted it a bit first. Then okay. Questions? Okay. If no other questions, I think I'll just end here today. Please go and digest and not say digest and disappear. Make sure it stays in your brain as nutrients. Okay. So to the next this coming Thursday, okay, next lesson, I will only have just a few questions left to cover. Okay, so maybe I shouldn't plan so much ahead. I guess homework will still have problems, right? Am I right? Okay, so I will expect the homework might take a lot of time, okay, as usual, as normal. Okay, then maybe I'll also return some of the homework that I've been holding on to for a very long time already. Okay, so let's not plan ahead. Next week, okay, our lesson, we are predominantly looking at covering our 2019 papers. Then I realized that in week 6, okay, we have your mid-year exam, okay, starts in only Friday. So in fact, we will get 3 full lessons on week 6. So that means that we will have some time for revision. Okay. I'm contemplating between whether to give you the 2018 paper. Do you want me to go through the 2018 paper? Sure. Do you want me to give it to you? I will give it to you, okay? Then should we spend week 6 to be covering that paper? You want that? Or do you want me to see what happens when the 2019 paper comes, then maybe place more focus on certain areas? It's a mid-year exam paper. Yeah.
But is there some questions like out of syllabus?
Yes, there are. Okay. But definitely your syllabus is a subset of the Set 5 syllabus. Yeah, you all know subset, right? Okay. It's you guys study your Emacs already. Okay, you studied that just this year. I'm going to revise that. Okay. In fact, proper subset, right? Yeah. So it's a different syllabus from the Set 5. So on that note, okay, also I want to remind you, for O-levels, when you receive your paper, please make sure you check your subject code. Okay, make sure you take correct paper. Don't end up you take, then after that, end up got modulars, got your sum and product rules that you don't even have in your syllabus, and then you silly went through and sit through 2.5 hours, okay, of a paper that is not in your syllabus.
So what's the modulars?
That's why it's not in your syllabus, okay? Yeah, so please make sure you take the correct exam paper, okay? So I'll give you the 2018 paper on Thursday, right?